What's up? I'm Austin. I'm here with Eda and Carlos. We're on week 2 of this Web2 to Web3 curriculum. And in week 2, it's all about scripting, right? We're going to dive into how to write scripts to talk to the blockchain. We're going to look at providers and signers and Ethers.js and format ethers and parse ethers, things that you run into all the time as a builder. But if you haven't yet, we're going to get you exposed to them. Hopefully you've gone through week 1 already and you are an Ethereum power user. You've had a bunch of frustrating moments with wallets and gas and all sorts of stuff like that. And so this like what did we do before? We did MetaMask, we used Etherscan to check things, we used like Uniswap, we did an ENS domain, we even took out a loan on Aave and talked about like that part of the ecosystem and DeFi. So DeFi, DAOs, NFTs. I don't know if we did much DAO stuff, but we did a multi-sig, right? We were part of a multi-sig. So hopefully you've gotten enough out of the first week that you can just go use Ethereum and get through some of those frustrating times. And now we're going on to week 2 where we're going to talk about scripting. And really, if we only had 1 hour, we would have you go straight to Solidity and start building smart contracts. But since we have you for this extra time, we're going slow and we're going through these other things and trying to leave as few blind spots as possible. All right, are we ready for week 2? Carlos and Eda, how are you guys feeling?
I'm ready to go. You know, I always like to start like coding first, because I guess this is like a more like bottom to top approach, right? I like to code stuff and then I start understanding things from there. You know, some people might prefer like understanding the theory, the ecosystem, or whatever. But for me, I always
get your hands dirty.
Yeah, and then from there, I keep building from there. So this is my favorite week for now, at least.
Yeah, awesome. I'm super excited. Like these are very, I think, primitive stuff, which a lot of times are like not super dived into. So I think it will be like nice to go through them.
Awesome. Awesome. Okay. So I think, Carlos, are you going to kick us off? Like what's the best place to get started?
I think from the beginning, right? Like let's start with an empty project and see what happens.
Sounds good.
Okay, can you enable the screen share?
Oh, yes, I forgot the screen. There we go. Now you can share. And I'm going to just basically follow along on my own machine too. So we'll probably have different versions of Node. Let's see, what is my Node version?
So can you see my screen?
We've got a background. Yep.
Okay.
Beautiful sea.
Okay, now this is a console, right? And my IDE. Okay.
Yep, got it.
Perfect. Okay. So I just created like an empty Ethers scripts folder, and so yeah, maybe we should start with the requirements, right? Like we will need Node.js for this. Not sure if we want to cover how to install Node.js, but it should be pretty easy to do there are like plenty of tutorials online. What I would recommend is using something like N. I don't know, guys, if you have heard of N before. It's just like a Node version manager. So you can.
Is that like NVM? So NVM is another one, right? Is it a similar thing but different? Okay.
Yes, cool. I think it's the same thing, right? So yeah, as you can see here, I have like 3 versions, so I can pick whatever I want, and it will change in my system like in 1 second. So this is super useful when you are working on different projects that require different versions. So right now I'm in Node 16, I think. Yes.
Me too.
Okay, cool.
I've got 14. I'm a bit back.
Perfect.
yeah, that's perfect. That's perfect. So maybe we will encounter some issues with the version. Okay, so maybe any of you want to explain what Ethers.js is before I install it? I don't know, Eda or Austin. I leave it to you.
It's just like a JavaScript library to help you communicate with Ethereum, I think is a good way to put it. Like there's going to be a lot of helpers where once you go talk to Ethereum, Ethereum's going to give you things back like big numbers. And like, what the heck is a big number? In JavaScript, the numbers are so big in Ethereum that in JavaScript, we can't even track them. So we actually create a special object to track numbers. So things like that, just like all these helper functions and features that are going to help us communicate with Ethereum, format things in certain ways, talk to smart contracts, send value around, create signers and wallets. All of that stuff is going to happen within Ethers.js, which is just a helper JavaScript library with very few dependencies. Rick Moo has created a library that is very lightweight and used by a ton of people in the space. And I think you mentioned Web3.js. We should probably also mention that there's an alternative to this that's a little older called Web3.js that is also just like a JavaScript SDK that allows you to, or library, I don't know what the difference is, a JavaScript library, a little lightweight library that lets you do a bunch of things like talk to things on chain and format values and stuff like that.
Yeah, but for some reason, it seems that most of the people are using Ethers right now. So yeah, so we will go with Ethers. Okay, so first thing, let's like start the project with npm init. When you install a node, npm should be there for.
So we need to be in a specific folder, though, right? Is
Yes.
that right? So cd and like actually make a directory and everything. Is that right?
Yes. Yeah. Sorry,
okay.
I already created like this Ethers scripts folder. So yeah, you probably want to do that first. Yes.
I'm going to do that too. So make directory Ethers scripts and then cd into Ethers scripts.
Yes.
And then npm init.
Yes.
All right, I'm in. Here we go.
And I think like we can leave the defaults at least for now. Okay, and now I'm going to do like a little thing. This is just like a personal preference, but let me hear what you think about this. So by default, when you have like a node, let's create like this test.js file. Just 1 second. When you have like a node program, you usually do things like whatever leaf and this equal to require whatever leaf, right? So this is called CommonJS. This is just like a way of doing imports, right? So what I like doing is like switching this mode to the ES6 import, right? And I will explain why I prefer that. But to do that, you can do 2 things. You can create like a new property here called type, and you just write module. You can also
type
have
module. Okay.
Yes, type module. Oh, is that the font size big enough?
Oh no, you're good. No, got it.
Okay,
no,
okay.
it was the accent that I couldn't read through. I was just hearing it. It's my old man ears.
Okay. So when you have this, you can also have, instead of test.js, you can also do test.mjs. It will do the same thing, right? That's like module.js, but I prefer like to set up like on the project, so you don't have to do anything else. So in this case, you can import stuff like this, leaf, and then from whatever leaf, right? So this is the same thing that you will do in React, for example, in the front end, right? So that's what I like it, because it is the same thing. So you can do the same thing in Node, and in React, when you use Webpack or something like that, it will compile the same thing. So I prefer to do this because I guess interoperability, right? So you can like copy and paste the code from the backend to the front end. So like I said, this is like a personal preference. You don't need to do that if you want, but I tend to do it on all my projects.
Sounds great. Okay. So, and again, like, because we're using Create React App, or like maybe you're using Next.js, something is using Webpack. And so all of this stuff is going to use imports already. So it's great to have your little script be copy pastable into Scaffold ETH and everything eventually. One thing, you created test.js and I created index.js. Is that a preference thing too?
Oh,
does our file need to be something specific, or does it not matter?
Like, we are going to call our script directly from Node, like test.js or Node index.js. So it doesn't matter.
So create whatever JS file you want there.
Yeah. Okay. I'm actually going to delete this one. I just created
to show the imports.
Yeah. Okay. So I guess now we have the project set up. Let me open a terminal here. Okay. So the first thing that we want to do is install Ethers, right? Right now we don't have like any dependency installed. It's just like node. So let's install Ethers with npm. You can say I or install, I think, and it's just like this.
npm install ethers. Send it.
It will take a few seconds, and you will see that your package.json, it will update.
Has a new dependency. Yep.
Yes.
And there's a package lock that comes along with it. Very
Yes,
nice. And we've got a new node modules folder.
Yes. So the log JSON, because if you see here, you can see that this means that it's going to install like any Ethers version up to, I think, 6. So 6 is not going to install, but it's going to install like 5, 9, 9, or whatever. But if I push this to GitHub and someone pull down my code, they will do like npm install, and that will install all the dependencies. But that will look into the package log JSON, which is because here you don't really know the version. You just say here, I want to install this version or app. But on the log file, there's like
it's
the actual
specific version.
Yes.
Yeah.
So you see here is like the, well, not this one. So somewhere it will be like the individual version or
somewhere in there. That's what the package lock is doing. And you do add it to your Git. Is that right? Like the package lock goes in the Git. So then if someone does a Git clone, not only do they have the package, but they have the package lock.
Yes.
And when they do the install, it gives them the exact version that you were working with.
Yes. The log is just like to lock in like a specific version.
Cool.
Okay. So now we have Ethers. So now we can create a new file. Let's call it let's call it providers, because we are going to start with providers.
We're going to touch providers.js.
Yes.
Got it.
Okay. Now I have an empty file, and remember we are using ES6, and so let's import Ethers.
I always copy and paste these lines. This is good to go through like slowly and type them ourselves. It's good for me.
Yeah, no,
like just for my brain.
Yeah, sometimes I do the same, right? Like if you go to Ethers, like the package or the GitHub, that you will probably read the instructions and you will just like copy and paste. Yeah, I don't know.
Yep.
I'm just like playing it fancy here, like
That's
typing
good.
all the stuff.
Yeah, no, it's good. That's what this is all about, is going slowly through it so folks at home can watch and follow along and understand things and digest. Okay,
so I think Ethers, like Austin said, provides like a bunch of utilities to interact with Ethereum blockchain. But I think like one of the more powerful concepts in Ethers is the concept of providers and signers. So I think we should start with that, right? With at least with providers. We can get to signers after, but let's start with providers. And I come from a web, like traditional web, or maybe Web2 development. I don't know if that's how people call it now, like Web2 or traditional Web2 development. So the mental model that I have when I think about providers is just imagine that in your Web2 application you have like a third-party service, like Firebase, for example, right? You use Firebase to store some data, and in order to do that, you will need some kind of API key, right? Which probably Google is going to provide that API for you, and they say, okay, use this API, and then with that API, you can access Firebase and save some data. So Google is acting as a provider. So this is, if we move to Web3, remember that we are trying to be decentralized. We want to access the Ethereum blockchain, right? And we need a provider for that, right? So that is like the mental model that I have. So it's like accessing like a service. So I'm using a provider to do that. And since we are trying to decentralize and be decentralized, you can choose a bunch of different providers, right? Like you have like, for example,
it can be any node. Like this node right here could be a provider for us. And I could just point to that IP address. Any node on the network that's communicating peer-to-peer to all the other nodes, any one of those nodes can be a provider. Sorry, go ahead.
No. I was going to say, like, people usually, before like sharing their own node, what they probably use is something like Infura, right? Or Alchemy. They're like two providers. I guess those are like centralized companies, I guess. but whenever you want, you can also, like Austin said, set up your own provider, right? Like, yeah. I think maybe now is a good time to explain what you have behind your back, because I'm sure that people are wondering from since the beginning, like, what is that like matrix like?
Whoa, yeah. So this is an ETH. This is an ETH. It used to be called an ETH2 node, but this would be the validator, or no, this is the beacon chain, and this is my validator node. And when we merge, and it's all talking to this right here, which is my ETH1, like layer 1. So this is like what a Geth node is, or this is Nethermind, and then this is Prism beacon chain and Prism validator. But basically it's the stack that you need to have the whole chain locally. And I'm not mining on L1, but or on layer 1, but technically I will be mining blocks with my validator. I'll be validating when we move to proof of stake. But just consider all of this stuff behind me, just like one node of the network that's talking peer-to-peer to everyone, that has the entire state of the blockchain ready to go. And you can ask it, what's the balance of this address? Or what's this specific variable value in some smart contract? So basically this thing is talking peer-to-peer to the rest of the network, and I can talk to it as a provider using my web app or one of these scripts, and it'll just make an HTTP request to the RPC, and the RPC will return, depending on what I ask for, certain things. Is that a good way to put it? Like, it's kind of like a little API that I can call to and ask it certain things. What block number are we on? What's the balance of this thing, etc.
And you don't have to trust anyone, right? I mean, it's your own node. So it's not like a company giving you the information. It's like your own node. I guess that you have to trust like the software that you are running.
Yep.
But still, right? Okay. So the quickest way to, I think Ethers has this get default provider. I don't know if you have ever used this, but you can use like this default provider all with Ethers. But it's not, this is like only for testing purposes, right? Because this is going, I think internally, Ethers just use like some non-API free tiers from some services. So this will break, right? If you put like 10 requests in a second, that this is going to break. But this is the quickest way to instantiate a provider. But usually what you want to do is getting like I think Infura or Alchemy. I don't know. I always use Infura. I don't know why, but I think I started with Infura, so I keep with Infura. So Infura, let's check the website. But I think it allows you up to I think it's 100K requests per day, something like that, for free, right?
And what they're doing is basically they're running a bunch of these, and they have like a load balancer on top of it probably. And that means they have to keep all their nodes up to date and all of them in sync. And then they have this whole, thousands of people making requests to it, trying to get the information from the chain. And so they have to charge people. And so you as the developer probably end up with, some free tier at first, but then as you push your application farther and closer to production, you'll probably want to get a more advanced Infura and Alchemy key, so it doesn't fall over in the middle of the day when you hit that 1,000 request limit.
Yeah, so the way to instantiate that Infura provider is just doing, I think it's Ethers provider. Let's see how it was. It's
like a JSON provider, isn't it?
I think it's new, right?
That's the one we're doing.
Yes. Providers, and then it's JSON RPC provider,
and
that would be like the Infura ID, right? Infura ID, okay. So
no, that's going to want to go to an address, right? The Infura ID probably won't go into that probably needs to be an Infura provider. We do want that JSON, like I'd steal that JSON RPC provider and tell it to go to localhost port 245 and talk to this one. But I think if you want to talk to Infura, I think it's a different provider. Let's see. We should probably pull up the Ethers.js docs too. And
I think
this
something like something like this. I have it here. Yeah, let me paste it. let's use the template syntax.
There we go.
Something like this, right?
Yep.
And this will be on your panel in Infura. Okay. So something like this, right? This will work. So now what we need is some Infura ID. I have some, but usually when you use this can be seen as an API key, right? So usually when you don't want to expose an API key in your code, because if you push this to GitHub, like everyone will have access to your.
And is this the secret key? Like from Infura, you have like a key and then a secret.
I think
this is just the key.
The public,
and if you
right?
keep the key, if you keep the key secret, then you don't have to worry about it. But with a lot of web apps, you will deploy the app with the key in it.
Yes.
And then you'll have to set some security that says only allow requests coming from mydomain.com. So then once your domain goes live, then only requests from your domain count toward your rate limiting on Infura. But for now, let's just keep the key, and we'll keep the key quiet, and we won't have any of those domain security issues. We'll just keep the key in like an Env file or something.
Yes.
Or
so
maybe just paste it right in.
Let's do that real quick because it's super easy to set up. We can install .m. It's just like a package to manage these environment variables, and it's super easy to use. Let me install it, and I will show you how to use it. It's already installed. Let me.
Here's the Infura provider too. Oh, .env, nice. No, these are great things to go through. I like how we're like going through these slowly and kind of covering them.
Okay, you see here, like it's just super easy to use. This is the one that we want to use because we are using ES6. So let's just paste this on top. And usually what you do with this is create .env sample. And then in this file, you will have like, I don't know, Infura key. And this, you leave this empty, right? But then when people clone your repo, it will see that it has like a .env example file. And maybe in the instruction, you can say, okay, now when you have this file, you just have to copy this file to .env. And you will probably also want to gitignore this file. I might be doing like a bunch of things at the same time. Sorry about that, but
no, this is great. And we're covering everything. So it's going nice and slow. Like take your time, keep covering it. I think we're doing a great job. I'm following along.
Okay, so this gitignore file is just a file that tells Git to ignore some files. In this case, we want to ignore node modules because we don't want to upload our node module folder. That folder will be populated whenever the person that cloned your repo do like npm install. And we also don't want to push the .m file, but we do want to push the m example file. Okay, so now I can copy this and I can paste here my key. So let's do it secretly if you want. Let's do it this way. I'm going. I mean, it doesn't matter. This is like exposed in a scaffold if, but just to. Okay. Okay.
I'm in my own Infura, kind of getting my own Infura key set up too.
Okay.
So I'm going through the same thing.
Okay. So now what we can do here, since we imported like .m config here, we have access to the environment variables. So we can do process. I think it's process, right? Process dot. I think env, and it should be Infura. Okay, I think. Yeah. For some reason, let me wait. I'm going to. For some reason, I don't have the Node.js. Yeah. So any questions so far? Like Eda or Austin, anything that maybe is not clear?
So in this case, we're using a JSON RPC provider. We should note that there is like an Infura provider. If you are like all of these different, like this is the best way to do it because it's the most generic, because we can paste in an Alchemy address with a key. We could paste in an IP address, right? But there also is an Infura provider. Yeah, if you go to Ether, yeah, I feel like we should probably just like highlight the Ethers docs. They're kind of hard to look through sometimes, but this is where a lot of the information is going to be. And there's even probably an Infura provider there where you just put in like, yeah, there is Infura provider, that second one.
Yeah. Oh, second one. Oh yeah, this one.
Where in this case you're just saying what network. So the first argument you put in is, you know, Rinkeby or Homestead or whatever. Homestead is mainnet, by the way, and then you put in your API key. Yes. So instead of like crafting the URL, you could just use this Infura provider if you wanted.
Yeah, like like something like this, right? Providers, Infura provider, and saying, and this will be this thing, right?
Yeah, there we go.
This would be, yeah, like Austin said, like this might be like more generic, but yeah.
Cool. Just wanted to point that out. Just say that there's some other options.
Yes.
Just so we know.
Like Alchemy, Etherscan, Cloudflare. Yeah, you have a bunch here. Okay. So which one do we want to keep?
Probably just the JSON one. After all of that, it might be easier just to have the generic JSON one, just so we can plug some different things in there.
Okay, so now we are connected to a provider. So what should be like the first thing that we can do? What do you think?
Block number? Can we like, the first thing I usually do is like, what is the current block number? Just so I get something back and I see that we have something coming from it.
So
and that lets you know like how big the chain is, basically, right? And the biggest chain wins, and we'll cover that on the very first day probably. But yeah, getting a block number from a provider, I feel like, is the, are you alive and are you tracking the chain the same as Etherscan shows, right? We'll get the block number here, and then we'll go to Etherscan and look at the block number and make sure those things are keeping up in sync.
So a question, what do you think that this is going to
the trick? Yeah, it's a trick. We need an await, right? There's no async await here. Yep. Yes. Okay, let's go through it though. If you're a brand new programmer, you grab the provider, you say get block number, you run the thing. What does it do when it runs?
And you're ready to see the block number, right? You're ready.
Give me the block number.
Oh,
wah wah! It's a promise.
So yeah, if you are new to JavaScript, like maybe we can like post like some links to this stuff, but you will probably need to read something about asynchronous code and promises and callbacks and async await, right? So yeah, the thing is that this is when we execute this line, the code doesn't stop here. Like it just keep going. So it just like print the promise. So we need to wait until the promise finished to see like the block number. And remember that I mentioned at the beginning that I like this way of doing it, like the ES6 module type. This is another reason that I like, because you can use await just here on the main thread. When you usually, if you don't use this module, these ES6 modules, you need to do like a function, and that function needs to be async, and then you can use await inside. But with ES6, and I think node 14, I think, you can also use await outside of any function on the main thread. That's another reason that I like these ES6 modules. Okay, what about now? Should it work?
Did we get a block number? Let's see what happens.
Yes.
Hey, and it's not even a big number or anything. We just get a nice current block number. And oh, that's great. And let's go check Etherscan real quick and make sure that's where we're at on Etherscan.
Okay, we got like 629. 629. Oh, 629. Yeah, here.
Yep.
So we just got like the latest block number over there, right?
Yes. Yep. So if we write again, we should get like a new number. Yeah, 34.
Oh man, a bunch of blocks passed. Yep.
Yes.
Exactly. Yep.
But now let's do something like more juicy, right? Because the number, I mean, it's nice, like Austin said, just to get like the
We're
number.
connected. We know that they're out there. Yeah.
But you can really do much with the block number. So okay, I got the block number, but we can do something like we talked about ENS last week, right? So Ethers have, I'm going to comment this. Ethers also have a way to resolve ENS names to addresses, right? So when you're in a provider, you can do something like provider, I think is name, resolve name. Yes. And let's do, it was like ATG, Austin, your address?
Yeah, atg.e. Austin
Okay.
Thomas Griffith.
Oh, nice.
I didn't know the T.
Yeah. Middle name. There we go. atg.eth is, oh,
and
wow.
now
Provider.resolve name is what we're doing. Cool.
Now let's see. Boom. Is that your address, Austin?
Yeah, it's 3-4. Yeah, that's me. That's me. Is that, you're like a magician? Is this the card you picked?
Okay, so
that went to the ENS contract and it put in atg.eth and it got back the address. So it went and talked to a specific smart contract. And in this case, Rinkeby has built a function for you to go talk to that specific contract. Normally we'll go talk to random contracts and we'll use something else. But in this case, we're interfacing with a smart contract with a custom built interface that Rinkeby put together, just because this is a specific contract that you're going to talk to so much. He just added the functions to allow you to resolve names and look up addresses.
Yes, and also maybe you might remember from last week that we were complaining a lot about people when we were on, I think it was Rinkeby, and we were connecting to any app. Like they didn't resolve the ENS back, right? So because when you connect to an app, they can only see your address, right? So when with your address, they should go to mainnet provider and get back the your ENS. So you can also do this the opposite way. So now I have an address here. Maybe it sounds familiar for someone, but I'm going to do lookup address. This is the other way around. So we did like resolve name, and it goes from an ENS domain to an address. A lookup address do the opposite. It goes from an address to an ENS name. So let's paste this address. And let's see here. I'll comment this. So this address is, and let's see who is this person. Oh, look at this. Look at this.
That's me.
Edit tweets. I thought maybe it was going to be Vitalik, but it's edit tweets.
Yeah.
I thought it was Stanford.
It could be Sanford too. We got so many identities.
Yes. Okay. So what next? Maybe something that we can, because we didn't mention it.
Maybe.
Yeah, balances. Because we didn't. Not sure if we say it, but when you connect to a provider this way, you only have read access to the blockchain. Only read. You can only read data from the blockchain. You can write or you can't send any transaction, because for that you will need a signer, which I think we will get there later. But let's keep with providers. So another thing that we can read is balances, right? So let's get the balance of, as you mentioned, Vitalik. I'm sure that he has more ETH than us. So let's check his account. Vitalik.
Yeah, I bet he does.
Has okay. So for this, you can use. I think it's just get balance, right? Get balance. Yes.
Is it balance? Or is it get balance? Yeah.
Yes. And here
balance of is like in a smart contract, I think. Yeah.
Yes.
Awesome.
And here you have an address or name, so you can use an ENS or an address. So let's use Vitalik's ENS. And what do you think is going to happen here?
Ooh, this is another trick. Yep. So normally we would think we would get a number back, right? We would get the balance of this address. But since we already alluded to, numbers on Ethereum are so big that JavaScript can't even track them. So what we're going to get back here is probably this some kind of a big number object, and we can learn how to deal with that. Yeah. So you as the developer, you're like, okay, Vitalik's balance is big number underscore hex underscore is big number WTF. Don't worry, developer. This is just because it's such a big number that we have to store it in hex. JavaScript can't mess around with it. But how do we convert this into something a human can see, Carlos?
I think you also mentioned last week, because the reason that Solidity or the EVM doesn't have, use this notation or these big numbers is because we don't want to deal with floating points, right? Because that is hard to do, and it will require a lot more logic. So they just say, okay, let's multiply like every number, up to the 18. So we have like these big numbers. But then when you do like the opposite, when you go from JavaScript and read a variable from a contract, you are going to get this big number, because if not, it will overflow. Maybe not always, but in some cases can overflow. So Ethers also provides some, because I guess you can do this. Let's do this first. Not to number. Don't do that. But
let's try all of them and see what they do. Yeah.
Okay. So yeah, because if you do to number, that is going to try to convert it to a number, and that might overflow and break JavaScript. But if you do it to a string,
with Vitalik's balance, but not with my balance.
It won't happen with my balance. Yeah.
Let's see what happens here. ToString. We get a promise.
No. Yeah, but this is because we need.
You have to await that whole thing. There we go, and then go ToString. Yep. Perfect little thing though. Like a developer could get stuck on that little thing for 10 minutes and like, what the hell is going on? So yeah, there we go. Look at that.
So I hope that he doesn't have this kind of ETH, right? This is not ETH.
That would be a lot of ETH.
Yes. So this is actually is Gwei, right? Is Wei or Gwei? Is Wei, right?
Not Gwei. Gwei would be like what we measure gas in. This is Wei. WEI.
Okay,
Yep.
Okay. So let's save this here and do this.
Basically, what we would do is go over 18 decimal points and put a decimal in there. Is what you would do if you were manually looking at this.
Yes, like counting this, and maybe it should be
18. Yeah.
Yeah, I'm not sure if it's going to be like 421 or 4,000.
I don't know.
Let's see. Okay, so Ethers have some utils to deal with these big numbers, and one of this util is called, I think, is format. Yes, format, right? Yep. Yeah, I always get confused because there is like
we're here to not get confused about those. Yes. There's format ethers and parse ethers, and we want to show you at home, you're going to get confused, but we're going to keep throwing these at you until they stick.
Yeah, I think it's format because when you read, like a number from a contract or whatever, you want to format in order to display, right? And the other way around, when you have something that you want to send to a smart contract, you want to parse your number to and convert it, right? So I think this should work. Okay, so it was 4,000.
Wow, that's a lot. That's ETH? He has that much ETH in his, holy cow.
Yeah.
Jeez, Vitalik.
Let's double check that. Yeah.
Let's look it up. Let's go to a disinterested third party, right? Let's go to Etherscan. Oh yeah, no, he has $8 million worth of ETH in his account.
Okay.
Good Lord. Man, could we borrow one of those $1 million? How many developers can I pay for how long?
Yeah. Maybe we can try with Ethers. Maybe Ethers have like some hidden function to get some balance from the Okay, so let's since we are here, let's show the other way around. We talk about the Ethers utils parse Ether, right? Yep. So if you want to send, let's say maybe
and
today,
it has to be a string. Make sure you put a string around this. Don't put like 1.0. You're gonna have a bad time.
Yes.
You need to put 1.0 in the quotes. Yep.
So let's do 1.5, and then this should return like the. So this should be like 1.eth is.
Yep.
This way, right?
Yep.
Okay, let's see. Yeah, you see, so it just compared to the big number, and if we do this to a string, it will show the actual number. Yeah.
And if you did ethers.utils.format ether around the parse ether, you should get back to 1.5.
Yes. You wanna do it? Yeah, let's do that.
Sure. There we go. Yep.
This makes sense now. Okay, let's see.
1.5 ETH is 1.5. Yeah. We did it. Okay. So we've got format ethers and parse ethers, and this helps us go from and to big numbers. Sometimes it is an actual number though, right? Like if you have some counter that's just keeping track of like a uint8 in your smart contract,
yes,
you will just do a .2 number, and that's fine. But if you ever have a big number and you try to do a .2 number, you're going to have a bad time because you're going to get overflow, because it's going to try to take a big number and smash it into the amount of bits that you have to keep track of a number in JavaScript, and that's where it's going to fall apart. So in your app, as you're building things, say you need to pull down a couple of these big numbers and then do some math. You don't want to convert all those big numbers to JavaScript numbers and do the math within JavaScript. You actually want to do the math here as a big number. Maybe let's add two big numbers together and show that off real quick.
I was saying,
or something along those lines.
Yeah, I'm going to say that you can use like big numbers have like some operation on it.
Yep.
For example, let's do like the Sanford balance, right?
Okay.
Sanford.
I think it's SAN. I don't think there's a D there, isn't it?
Sanford.
I think it's Sanford's. Yeah, something like that.
So you can do with big numbers. You can do things like greater than. Yeah. So this you can do something like I don't know.
This is perfect. Yeah.
Let's do like let's do like a old school like if here. So Vitalik.
So Vitalik has more money than Sanford in this case. Yeah.
That's probably, I mean, I'm going to do like the else, but I don't think that we are going there.
Maybe on localhost.
Okay. So we are, because we don't want to do operation with big numbers, we don't want to convert it to number and do operation in JavaScript. Like big numbers have this kind of operators when you can do like compare or maybe add or something like that. So let's see what happens here.
On line 22, you have Sanford twice. It's like a small thing, but you might want to put Vitalik. There we go. Yep. Yeah. And then I think so Vitalik has more than Sanford. We can see that for sure. Now, what happens if we take the Sanford balance and we add like 5,000 ETH to it, right? So I think you could do Sanford balance dot add right in line. Oh, I see. You're going to do the whole thing. Yep.
Yeah, I think if you want to add like, what do you want to add, like 5 ETH, for example? Right?
Yeah, let's add 5 ETH.
Let's add.
No, let's add like 5,000 ETH to make sure we're. So how many? So he has 4,000, right? 4, so let's add 5,000 ETH to it. Good.
So
Lord,
not sure if this will work, or I have to convert it.
Yep, you'll need to do utils. You'll need to do a parse ether.
So something like this.
Big number from. Yep, you could do that too. Yep, I would say to do a parse ether just because we know format ether and parse ether, but this is another way to do it. Is just create a big number from 5,000.
Yes.
Okay, let's see what happens now.
Let's see what happens with Vitalik now.
Come on, Sanford. Have more money than Vitalik.
Oh.
Uh-oh. What went wrong? Maybe Sanford balance needs to equal. You need to do Sanford balance equals Sanford balance add.
Yeah.
Yeah, and it's const, so it's not going to like that either. Yep, there we go. Now be bigger. What are we waiting on?
Oh,
is it like querying? Oh no. What?
So,
okay.
Let's do this first.
Let's do some console logs. We got something weird going on here.
Sanford balance. Let's say Sanford balance to string. I think the wait is just like us connecting to the provider. I think
it's
like
you asking Infura for the information, right? Infura
yes.
is super slow. Okay.
Okay. So let's do like this format. No, utils format ether. No, not format. No, yes, format, right?
Yeah, that's right. That's going to display it, and you take out the toString. Yep. And I think you need one more parens. Yep. And maybe like copy that and paste it so we have italic balance also. Just make sure we're seeing all of our variables correctly here. Nice.
And maybe he just like made a transfer right now with.
He's messing with us, throwing some more ETH in his account to keep up with Sanford. Oh man, this wait time on. Okay, there we go. Maybe wait, yeah, what is happening here?
It's really just return a big number, so not sure.
Is add not the, let's see. This is good. We want to have these problems. So we want to go through it and figure it out. What are we missing here? Why can't you just add? Yeah, it returns a big number of the value plus the value. It should, that should work. And it's not. What are we missing here? Try parse ether, just in case. You know that big number 5,000? You know what? I think it's doing 5,000 way. Because it's creating a big number, but the big number is still only at 5,000 way. I think we want to just do parse, parse ether instead of doing that big number from, because what you did is you created a big number of 5,000 way. So it was the right format, but we're only adding 5,000 to it. I think you want to just stick to parse ether and format ether at first, and not have that big number because that's going to confuse you.
What do you mean?
There we go. I've got a good feeling about this one.
Okay. Yes.
I'm glad we went through that though. That was a really good exercise. Why isn't this number? Why are we getting this small number? And we have to really output it. There we go.
Yes.
Stanford has more money than Tyler. We did it.
Yes.
So again, just to go through this stuff, we've got providers. We're asking the blockchain, who is behind this address or behind this name. We're asking the blockchain what is the current block number. And then we're getting in here and we're actually doing some conversions between the format ether and parse ether to go to those big numbers. And it's just, this is you'll deal with this stuff on a daily basis if you're a decentralized application builder. So this stuff is just so good to go through and go through this a few times and test your assumptions and have lots of console logs and get it so it's clear in your mind what's going on. Even us that we've been building these things for a year or years, we still it took us a few tries to get it exactly right.
Okay. What I have next in my list is wallets. I'm not sure if you want to cover, if Eda or Austin want to cover anything else, but the next thing in my list are wallets. So up to you.
Providers, signers. How about just a small little bit of contract interaction? Could we ask the balance in DAI of each of these people, right? So get Vitalik's balance in DAI and get Sanford's balance in DAI, because right now we're getting their balance in terms of the ETH balance, right? But to get your DAI balance, we'll go to a DAI contract and we'll ask for it, and that's going to bring up things like the ABI and the artifacts and stuff like that.
Yeah,
so
I mean, I think that was planned for another day, I think.
Okay. No, that's fine. If we're already here,
but we can go. I mean, it's up to you.
No. If we're gonna hit that tomorrow, let's hit that tomorrow, and let's look at wallets today. I'm down with that. I'm following your lead, Carlos. You go for it.
So yeah, my idea was to do wallets and maybe a little bit of signers, just an introduction of signers, because we need signers to send transactions. So I was thinking tomorrow maybe we can start getting some data from smart contracts and sending some transaction from the code.
Perfect.
So, is that okay?
Yep. Sounds great.
Okay. So let's create a new file called wallets.js. And yeah, I'm sure that you'll remember last week we created, I think, a couple of wallets through MetaMask, right? And it was it was it wasn't fast, right? Because I mean, it was fast because you have to create you just have to push some buttons, but you have to, get the mnemonic phrase and put it just to put it there and save it and all of that. So you will see that is going to be super easy to do in code. For example, with Ethers, you have several ways to go for it, but the easiest way, I think, is let's import Ethers first, and from Ethers, and yeah, I think you can do something like wallet. I think Ethers wallet. Yes, create random. So you can, with just that line, you can create like a new wallet, and let's do wallet.address. Well, let's also print the private key. I mean, don't do that at home.
Don't do that. But we want to do that. We
mnemonic.
definitely want to do it.
But
like Goosebumps should go off when you're printing a private key. Yeah.
Yes, and also even the mnemonic, I think we can. So I think this is like private key, and this is the mnemonic and phrase, if I'm correct. Okay. So if I just run this script wallet, it's going to create a new wallet and so the private key and the mnemonic. And whenever I run this script, it's going to create a new one.
And we kind of covered what a mnemonic is and how a private key is derived from that. What we're not seeing here is that this private key is probably private key number 0 of that mnemonic, and you technically could have a whole bunch of different private keys.
Yes, I remember, because we create one. I mean, we have one mnemonic on MetaMask, right? And if you remember, we will add like new accounts with the same mnemonic. So yeah, actually, let's dive into that, because I think it's interesting to see how that works. So let's check the documentation in Ethers, but I think that is something like from mnemonic.
It's like from mnemonic. Yeah, mnemonic, you do from mnemonic, and then within there is the path.
And the path, yes.
And I think that path you could tweak to have a different
the last one, the last digit.
That last number.
Yeah,
that's number. So weird. Why not have index? And yeah, I don't know.
I guess because maybe you want to use like a different path.
Path. Yeah.
I know. So let's let's do this. Let's declare my wallet. Let's see my wallet, and let's go with a old school for loop here. Let's 0, and let's do for
like 10 wallets or something. Yeah, cool. I love it.
Yeah, and then we can do and okay, so we can the path. Let's paste this one. This is the default, right?
I hope so.
Yes.
Unless he's trying to trick us.
So
and you want to delete the 0 off of there.
Well, yeah, I'm going to use like this template string.
Yeah. There we go. Cool.
Yes. Okay.
Oh, I like it.
Okay, and now we can say my wallet is equal to Ethers wallet from mnemonic. Yes. And then let's use this mnemonic, right? We have it here. And then use this path. Okay.
And if the very first address lines up, if the first private key lines up, we'll want to print the private key there too. Yep. Oh yeah, or the address. Yeah, cool.
And
we'll make sure the first one lines up with the 0, and then the rest of them should increment.
So let's do this, like to show the index, right?
Oops. Very cool.
And then this will be my wallet. Okay. So this is going to take it's going to create a mnemonic, and from that is going to derive like 10 wallets. And we are going to have like 10 different, not 10 wallets, like 10 accounts, right? It's a better term, I think, like 10 accounts or 10 addresses from that mnemonic. So if you run it.
Let's compare the very first one with the first thing that prints.
Yep.
9A. Yep, we did it right. We've got the same address and the same private key for the first one. And then you can see the rest of them would be those extra accounts that you would add if you were in MetaMask adding a new account or whatever. Very cool. Very good way to just demonstrate that too. Nice for loop.
Okay, so another thing that I wanted to do is whenever you have like the, you can go to MetaMask if you want and use this this mnemonic, and it will derive like the same addresses, right? And you could also, I think we didn't do this last time, like to import like a single private key. I'm not sure if we did that last time.
Oh no,
right?
You can do that in MetaMask is what you're saying.
Yeah. So let's pick a number from 0 to 9. I mean, which number do you like?
Key number 5.
That's 5. I like middle.
Okay.
There we
so
go. So private key number 5.
The address is start with 71, right? So let me import this private key to MetaMask. I have it here. Oops. Okay. Yeah. No, this is like that. Don't worry.
No keystrokes.
Okay. So here you can import an account.
And the way that we imported one was we created a mnemonic, but in this case, we're bringing in a specific private key, a single address. Cool.
I'm going to paste this here. Boom.
7-1.
7-1
Yes.
and ends on 5-5. So I think it's the same thing that we had here. 7-1 and 5-5. Yep.
Okay, so what if we wanted to create a wallet object given the private key, not the mnemonic? Can we do that in Ethers?
Yeah, I think so. So let's
from private key or something.
Yeah, let's start with let's save this private key. We like number 5, right? So let's going to comment this.
Oh, you just do new wallet and then pass in the private key. Cool.
Okay.
Here's the docs.
Okay, so did you paste it somewhere?
I put in the chat. It's just you just do new and then capital W wallet, and then inside of the parentheses you do the.
Okay, so it's new Ethers wallet.
Yep.
Like
and
this.
then paste in the private key. Yep. Nice. And then we could just do like wallet dot address or whatever.
Of course, like we are. I mean, it was funny that we created like the Env file and everything.
Environment file.
And then we are
and
just pasting
showing...
like private key here. So yeah, don't do that, please. Yeah. Like you should like just go here. I mean, let's do it, please.
Let's do it. That's a good idea. Let's do it.
So let's do like my wallet private key, and then this is like for the example. Now I'm going to be stupid about it because I don't want anyone to see it. I'm just going to do that variable equals to my private key. Okay. Now back. So this is the private key. So now we are removing this, and we can do something like process.
And now we can commit it to GitHub and not worry about that private key getting lost or something like that.
Yes.
Getting drained.
Okay. My wallet address from private key is wallet.
And it should be the 7-1, right? Let's see what happens.
Yes, the same. Oops.
Uh-oh.
This is good. This is good.
Yeah.
Okay. Oh, maybe it's like okay, wait. It's like the 0x.
You may need to take the 0x off. Yep.
Yes.
I bet so.
Yeah, like the 0x just indicates like there is like an X string, but you don't really need that. So this is
exactly the kind of thing we want to have, is weird errors like that. Like that error does not at all tell you you've got a 0x on your private key. You don't want a 0x on your private key. It tells you something about hex, and it's like, what is happening? Why give me that error? You at home would get so frustrated. But you went and you edited the env file and you took off the 0x of the private key, right?
And it's still not working, so.
Oh, okay. That didn't fix it.
No.
Darn it. Okay. So something is undefined.
My wallet. Let me check again. Well, I mean, let's let's print this here. I mean, we already we already have that. So
we don't need to await the wallet.address, right?
huh, oh. Oh, okay.
Don't we
It's not defined.
So I think, do we need to like pass our provider for the wallet?
I mean, it's not well.
No,
I'm not sure. I think only if you want to be a signer, right? Maybe
this is an interesting thing. The difference between a signer and a provider. I think you can create the wallet and then connect it later on to a provider. You could do a .connect. So in this case, we're just like locally creating the wallet and the address. I don't think it needs to be connected to a provider to get this to work.
We missed the .env config.
Got it.
Yeah.
Okay.
Yeah, I'm glad that these things are happening. You know.
Yes, exactly. That sucks that it didn't give us. So basically, what we would have done is we would have tinkered around for a while, and eventually we would have console logged that my private key, and we would have saw that it's undefined. Is that right? There we go. Yeah. Yes. So our private key is undefined. We're creating a wallet with an undefined key, and it's blowing up. So we didn't bring in the process env stuff. Okay, cool. And now it's right though. We see that we can create a wallet from the private key, and it does derive this 7.1 address that we were expecting it to derive. Awesome.
Yes. So I don't know what else. I mean, not sure how much time do we have left, but we can introduce signers if you want, or we can even do something with signers, or I don't know. How
that whole difference between a signer and a provider and being connected. Right now, we're not connected. If we wanted to get the balance of this address, maybe let's go through that. Like, okay, cool. We've created a wallet from a private key, but we don't have any kind of a provider here. How do we bring the provider into the mix? We could pass the provider in as we create the wallet, or we could like retroactively connect the wallet to a provider. And maybe we could go through both of those steps.
Yes. So
and then we can do like signers and contract interaction next week, I think.
Okay, so let's just like copy this from here. So I think this will just connect the wallet, the account to the provider, right? I think this is one way to go, and the other way is here, I think, just like at the second argument, right? Okay, so maybe what is signer? I think there's like a bool here called is signer, right?
Yeah.
So
maybe, oh yeah, so it's going to be a signer. Yeah, okay. I see what we're doing. Let's run through this. This is interesting.
Okay.
Because this whole signer versus provider thing is really interesting, and you need to kind of get your head around it, where provider is the connection and signer is the local cryptography stuff that's signing stuff.
So it says that this is a signer because it actually is, right? You can sign stuff with this signer, right? Like you could sign a message or encrypt a message even with the.
You could sign a transaction, right? Like if you were going to have like an air-gapped machine, you could have this script running on a machine that's not connected to anything, no connection to anything, but it has the mnemonic there. It brings in the mnemonic, it signs a transaction, and then it delivers you the signed transaction. And then you take that to another computer that's on the network and plug that in and broadcast your transaction. Basically the machine that holds the PK like never is ever connected to anything, and it's air gapped, right? You could technically do that, or assign a message. Yes, exactly. Hola.
That's right. Hello. Oh no.
There it is.
Oh, it's like a promise.
Wait, but it gave us back the.
Yeah, I don't know.
That was cool.
Like a promise with, but yes. So
then that signed message, so you could send hola and that signature across the network, and anyone can take hola and that signed message and recover, and they should get the 7.1 address that we are using to sign. And that never goes to a provider, that never connects to anything. All of this is happening locally.
I think it was something like this, right? A verified message, right?
Ooh, nice. Heck yeah.
I mean, maybe this is not for today, but
that's great. Let's do it. It's happening. So
let's store this here, like signature, right? And then we can print the signature, and we can verify. I mean, doesn't make sense to do it here. This will be in in another server, right? So you will sign this message and you will send it to someone, and that someone will verify that you are the author of that message, right? So this will be executed in another computer. So you have to pass like the message, right? And then
the message and the signature need to go across the network. Yep.
Yes, and then I think this returns the address of the signer.
Hopefully,
right?
Yeah, it should be the recovered address. Yep.
Signer address. Okay. Okay. So this will give us like the 711, right?
Hopefully. Let's find out. Yes. Hooray, it did. We were able to like cryptographically prove that that account signed that message. And a lot of times you'd have a timestamp or a nonce in there so no one can replay it. But that could be that, that in itself is like super powerful. You could build a whole Web3 app that doesn't talk to the blockchain at all. It just uses ECDSA key pairs, signing messages and verifying those messages. And I consider that to be Web3. Like, we'll see. Like, is it about decentralization? Is it blockchain based? Is it ECDSA key pair based? But yeah, there's a lot to go into there. But
yeah, I think
good demo.
We can go deeper on this, like on in the next days about signing stuff. But I think this was like a good introduction, at least. So the thing is that we aren't connected yet to a provider, right? So what is the difference, Austin? If I do, because now I can sign stuff, but what is the difference if I connect to a provider? What can I do connecting to a provider?
Still be a signer, right? Like let's go ahead and uncomment that. It's still like all of this should still work. Let's hit save and make sure it still works. I think basically it's still a signer, it still recovers, it still can sign messages. But now in this case, because we're connected to a provider, we can ask the provider for the balance of this address. Or we could, broadcast a transaction. But
what if like the last thing that we can do today is just getting like instead of connecting to mainnet, let's connect to Rinkeby. Let's request some Rinkeby ETH from the faucet, and then send some ETH to Sanford. I don't know.
Okay, cool. That sounds good. So we're actually going to sign a transaction then. You're going to do an outbound. Let's do it. Yeah. Let's see what happens. Yeah. Let's go for it.
Okay, so let's first, I think this is just like Rinkeby, right?
I think so, yeah.
Okay, so this is just like connecting to Rinkeby. So all this signing will be on a testnet, right? So we are not going to send like real ETH. So let's get some money first, right?
Maybe let's have it just like, let's comment out the signature based stuff and let's have it report the balance, and then we'll see that the balance is 0 right now, and then we can go to the faucet and
balance. And this is
so maybe you're writing a script that has a local mnemonic. Let's say we're going to write a bot, and when we send it money, it needs to forward that money on, or maybe split it. How about whenever this guy receives money, it splits it between all 3 of our addresses or something like that, right? So we're going to create a script. We don't want to copy paste in some other private key or mnemonic from someone else. We want to generate one on this box and use it as this signer. And then its job will be to check its balance. And then if it has some balance, send it on or something like that.
Okay, so what is happening? Missing provider. Maybe we have to wait here. I'll wait here.
Maybe. Not sure. Let's see.
Nope.
Maybe you need to go to signer.provider.getBalance or something like that.
Oh, that might be it.
And then does getBalance need to have the signer's address?
Signer.
Is that right? I have no idea. Let's see what happens.
Let's try.
Yeah.
Okay.
So yeah, I think so in this case, I think you want to connect the signer to a provider to get the signer to be able to send a transaction. But if we're just asking the balance, I think we want to just do provider.getBalance, right? Like, I don't think we even need to, yeah. Yep.
Okay.
Let's try that. Because signers and providers, yeah, that works. Signers and providers are different. A signer can do things like send a transaction. A provider can do things like get the balance.
Let's format header. Okay.
Nice.
So it should be 0, right?
Yep.
Nice.
Yep. Okay. Now let's hit the faucet. Awesome.
So where is the address? It's somewhere here. Yeah. This is the one.
And sometimes these faucets aren't working. You have to go to multiple faucets. Like the fact that it's on a test net means it can get attacked. There's certain different faucets that require like different socials be put in. The paradigm, I think paradigm is one of the faucets that's really good. If you just search paradigm faucet, but you've got it, and we've got a Rinkeby transaction on the way. Let's see if our wallet detects a new balance. So say this is some script running on some machine, and every minute it runs. All right. So now it's detected a balance. You want to actually like sign a transaction and send it out then. Is that right?
Yep.
So this is where the signer comes in, not just signing a message, but actually sending a transaction, right?
Yep.
Let's do it. That's a good way to close the day.
Okay, so now we have the signer here, and we can do send transaction, right?
Ooh.
And yeah, I think we will go deeper into this like maybe tomorrow.
This is a preview. Yeah.
This is a preview, right? So who are we sending to? I mean, to Sanford, maybe.
We could go to Sanford. Yeah, sure.
Yeah. So not sure if this is going to allow having an ENS here. What do you think?
Let's try it. Let's try it. That's a great thing to test.
Sanford is, and then
let's send him 10% of our balance. That's your challenge here.
Okay.
You'll have to do some math in here. Yeah.
Yes.
But that's good. Like formatting these values, doing math on them, like that's something you're going to have to do right away.
So let's have my balance here. And this is going to be a big number, right? As we talked about. And yeah, let's things here.
Got an extra parenthesis there. Nice.
Okay. So now what I want to do is send, what did you say, like 10% of this?
Yeah.
So it should be like my balance. I think it's div.
Yep.
And
in this case, you could do a big number, right? You could do a new big number and divide it by 10.
Yes. So
yep.
In this case,
that big number thing would have worked.
From I'm not sure if it's value
10.
Okay, like this.
Right. Let's see what happens here. I don't know. Let's find out.
Okay.
Maybe we should even like before we send it, like output it to make sure it's like the right number. I don't know. We could test it in prod too.
Yeah.
It'll either send. We'll see what it sends.
So let's await for this. But one thing is that when you do the await here, when the code reaches this, that doesn't mean that the transaction is done, that the transaction is mined. That only means that the transaction has been sent to the mempool, right? So and you already have like info of the hash and all of that. But if you want to really wait until the transaction is mined, I think you have to do something like tx wait. I think.
Let's put some. Yeah, let's do it. And I think you await that. Oh, you are awaiting it. So maybe put a console log above that and console that the transaction is in the mempool and here's the transaction, and then do another console log after that transaction confirmed or something like that, right?
Yeah, like confirmed.
Yeah, perfect. Or mined or something. Yeah, that should do it.
And maybe do you want to print something about the transaction? I don't know.
Yeah.
Do you know any of the properties like hash? Or...
I think that the hash is the most important part, right? Let's output
print
the whole
everything.
thing. This is good.
Let's print everything and see what happens.
Let's ship it. Let's see what it does.
Okay. I think this is going to break, but let's see.
Unsupported operation.
Machine provider.
Oh, did you connect?
Yeah.
Yep. Okay.
Let me wait one thing. Just in case. Nope.
It'd be provider.send transaction, which is really weird. I think maybe we need to use the signer to sign the transaction and the provider to send the transaction.
Or let's try one thing. Okay, this worked. No. Oh yeah, this is working now. I don't know. So it seems that when you, or maybe disconnect, just return something, and it has to be like signer equals to signer.
Ooh, maybe it creates a new signer. Yep.
Because when I pass the provider
now
here,
that works.
it works.
Okay.
So,
okay.
So it seems that ENS name result.
It doesn't like our name, Sanford Stout. Darn it.
So I mean, but the good thing is that we know how to convert back, right? I mean,
let's
we
do
know
it.
How to,
let's grab that from the other file, or grab it from. Yep.
Well, Sanford,
so this would be Sanford's address equals the resolve.
This should be provider. This is resolve name, right? Yeah. Like this.
It might be lookup address. I can't remember which one is which. We'll find out. Trial and error. This is how we'll find out.
I think resolve. Yeah.
Let's try that. See what happens.
Okay.
We may even want a console log on line 30 that says like we're sending X amount to
Sending ETH to.
Yeah, and then paste that address in. There we go. Let's see what happens.
Let's see. Oh my god. Oh,
sending ETH to null. Yeah. So maybe I think it's lookup, not resolve.
Okay. Might be, but this is on the mempool, right? I mean.
Yeah, no, resolve name should give you, no, you did it right. Resolve name, provider. Is it not sanfordstout.eth? Oh, it's on Rinkeby. We're on freaking Rinkeby. We have to set up a mainnet provider, resolve it on mainnet, and then get the address. It's the same thing we were mad about earlier. See, this is if you're a brand new programmer and you got to this point, you would be like, it's not doing what I think it's supposed to do.
Yes.
Grr.
Okay, so let's do. So this is a Rinkeby Infura URL, right? And this is Rinkeby. Provider. Need this.
Yep. No, this is really good. This is good to show that your app is going to have this. Your app is going to have a mainnet provider so it can resolve ENS. And then you may have some L2 that you're talking to or whatever network you're deploying to, and it'll be a second provider. And you'll need to use your mainnet provider to look up all your ENS stuff, but you'll need to use your normal provider to ship transactions to whatever network you're talking to.
So this balance is Rinkeby because we want balance. We want to connect the signer to the Rinkeby provider.
Yep.
But we want to check Sanford's address on mainnet.
Yep. Yes. Hooray. This is some complicated stuff. This is why we do this. Like, it's easy. Just go write a script. It's hard. There's more to it.
I'm just wondering what happened here, because we send a transaction.
Let's see. So if you send an address to no one, it's actually deploying a contract, right? If you scroll up, is the to address empty? Yeah, I think what it does is it looks at the data field and tries to deploy it as a contract, maybe? I don't even know. Is it on chain? Did it happen? We could go and inspect it.
Yes.
Yeah, contract creation. It deployed a contract.
Like, welcome to the contract creation class.
Yes, we just created a contract on accident by looking up the address and having a null to. So if we go look at that transaction a little closer, does it have like the bytecode of the key? Yeah, open that up farther. I mean, I think you have to have, wow, I don't know. There's stuff about like, I don't know what's going on in terms of if the EVM respects that as an actual contract or not, because it doesn't. There's no bytecode. Like if you were to call, does it have bytecode? There's like an is contract function in Solidity that checks to see if there's code at that location. It seems like that would be false in this case, and the is contract would actually fail because there's not bytecode there. That's for another day. That's for another day. We just did some weird shit though.
I think there will be like millions of contracts like this, right? Like people like sending
weird empty. Yep.
Okay. So now let's see if it works.
So now we want to go to mainnet, get the mainnet address, but then on Rinkeby, make the transaction. There we're sending ETH to Sanford's address on Rinkeby. Yeah. And how much ETH did we send?
It's 0.1, right?
Hopefully 10% of our value, right? Yep.
This will be, I mean, because the balance was 0.08. Okay, so let's see. I mean, this is confirmed, so it should be here.
Can we run it again and see that it like blocks on the? Can we just do the whole, just up and enter? Just run that thing again. It should block for a little bit while it's waiting for the because we have two waits, right? We have the awaiting the transaction at the start and then confirm transaction. It looks like it goes all the way to confirmed right away, and it shouldn't, right? It should wait.
No, but it took some time, right?
Let's watch it again. Yeah. It should take about 15 seconds or so.
Yeah, but this is just the transaction.
Okay, sending ETH. So right at this point.
Yes, but this is waiting. This is waiting.
Oh, there it is. So now it's in the mempool.
Yes.
Yeah, okay. And now it's confirmed. Okay, so those are the steps. It's like packaging up the thing and sending it to the mempool. Okay, the first await, it's in the mempool. And then the second one is it's mined into the block. Awesome. We did it. Yeah. Great work. And there we go. We actually sent some point. Yeah, there we go.
Yeah.
And are we sending 10%? We should check to see if it's the right amount. Is it right? Okay, cool. Yeah. Awesome.
And this is Sanford, right? Yes.
Yes, we did it. Sanford has some Rinkeby now. Awesome.
Cool.
The one other preview I wanted to give, if I could steal the screen for a second to show my script. Boop. Okay, so I did the same thing you did. This is the old script. This is the providers. What I want to show is how much faster it is. So this is the only difference here. I've got, I'm talking to this node right here, this Nethermind address, right? So it's a local IP address and then on port 8545. But remember how long that was taking to look up the different addresses and give you that information back and like what the block number is or like what my balance is. Watch how fast this is when you're talking to your own node. Boop. It's way faster, right? So say you wanted to get like thousands of balances, right? You wouldn't be able to do that by asking Infura. You'd want to be able to have your own node running where it has the whole state of the blockchain. It's talking peer-to-peer to everyone, and you're asking it for a lot of this information instead of going out to a server and coming back. I just wanted to show that off there too. Preview. Coming soon. You'll be running your own node and talking to it and building indexers to talk to your apps and so much more stuff. Thank you, Carlos, for the great introduction to scripting. I'm excited for week 2.
Yeah, that was like such a great intro. I think I learned a lot of stuff which I didn't know before as well. I got the Rinkeby mainnet part a bit later than you guys, but I got that too.
It's all the gotchas and the weird things. Like, I'm glad we went through those and like ran into those problems, because there are things that like your brain glazes over and says, of course, that's just going to work. But then when you actually try to prove it to yourself and it doesn't work, it's a whole different ball game. And I think it's good. Like, you as a developer at home, take the time to prove it to yourself and copy paste some of these things and prove, you know, these blind spots are here and they're everywhere. And you've got to cover these blind spots by just trying new things and see what happens.
And we will also get into testing this week, so we can test our scripts on our smart contracts, which is a nice way to make sure that you are not messing up anything. Awesome.
All right. I'll see you guys for the next one. Thanks, everyone. See you later.
Thanks.
Bye.
Bye.